Hi, everyone. This is episode 632 of the People Behind the Science podcast, and I'm your host, Dr. Marie McNeely. Today, we are looking forward to revisiting our interview with Dr. Glenn Rall, originally published on January 16th of 2015. Glenn's research focuses on how the immune system responds in the central nervous system following viral infection, with the goal of determining how viruses can contribute to disease in humans, including cancer. Over the past 25 years, Glenn and his lab have discovered novel roles for antiviral cytokines in neuronal survival, defined the mechanism of transsynaptic transport of viruses within the brain, and characterized how viral invasion of the brain can lead to both short-term and long-term disease. And in our conversation, Glenn discusses his very earliest scientific experiences, some of his exciting research projects, his passions outside of science, and more. So listeners, I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. I am thrilled to be here today with Dr. Glenn Rall. So welcome to our show, Glenn. How are you?
I'm fine, Marie. I'm fine. How are you?
I'm wonderful and excited to chat with you today. So listeners, Glenn is a professor at the Fox Chase Cancer Center, and he's also the leader of the Inflammation Working Group there and co-leader of the Immune Cell Development and Host Defense Program. Glenn also serves as an adjunct faculty member at Temple University, the University of Pennsylvania, Thomas Jefferson University, and Drexel University. He received his PhD in Microbiology and Immunology from Vanderbilt, and he completed a postdoctoral fellowship at the Scripps Research Institute before accepting a position there at the Fox Chase Cancer Center. Now, Glenn is here with us today to tell us all about his journey through life and science. So today, Glenn, we want to get to know you, not only as a scientist, but also as a person. So can you tell us, what do you like to do with your time when you're not doing science?
So your question is actually very well timed, Marie, because I've been married to this lovely woman for 19 years, and we have two daughters, and we just actually, about a week and a half ago, brought both of our kids to college. And because my youngest is now a freshman, so this means that we are very newly empty nesters. And so this is a bit of a change for us because, for the last almost 20 years, we've had these little urchins running around the house, and now we find ourselves with a bit more free time. So both my wife and I, and my wife is a pediatric audiologist down at Children's Hospital. So both of us have fairly busy professional lives, but we've been spending time a bit thinking about what else comes next for us. So prior to this, we were pretty actively involved in our kids' lives. I've always done a lot of volunteer work. Even when I was a graduate student, I was a big brother to a kid for 5 years. And so I suspect that now that the kids are gone, both my wife and I, and it's not clear if we're going to do it together or separately in two different ways, but we're going to get probably back actively involved in doing some community service and things around our neighborhood. The other thing, and this is going to sound potentially almost arrogant or lofty, but
continue.
Well, so I have to preface it by saying I've become a huge fan of classical music. So in Philadelphia, which is where Fox Chase is located, we have this amazing symphony. And rather by chance, we got subscription tickets with another couple, with some friends. And I just find this to be one of my happiest, most peaceful times. And so I've begun kind of amassing. I'm still old-fashioned enough that I like CDs. In fact, I've got a couple I'm looking at right next to my computer here where I've begun, sort of collecting these. And I find at the end of the day, I'll go home and I'll, review papers or do a little bit of work at the end of the day. And this is wonderfully renewing for me, which is a happy circumstance. So I've become, rather late in life, a classical music snob.
Well, that is great to hear. I must say, classical music got me through grad school. That's what I would listen to when I was analyzing data. Yeah.
What was your favorite piece?
Oh, that's a tough one. I'm a big Dvorak fan. So Serenade for Strings, love it.
Yes, you can never go wrong with Dvorak.
Yeah. Well, great to hear about some of these new hobbies that you're maybe re-entering into or getting excited about now that you have a little bit more free time on your hands with your kids out of the house, going to college. It's a very exciting time. So we're going to talk a little bit about science next. Can you tell us, Glenn, how do you describe what you do to someone who's not in science?
Sure. So our lab lies at the intersection of three distinct disciplines. So my lab is interested in virus infections that happen in the brain and how your body's immune response recognizes those infections, tries to get rid of those infections, and in some cases contributes to central nervous system disease. And so in talking with people who aren't scientists or who aren't virologists or immunologists, there are clinical connections and links to this. So hyper or overly aggressive immune responses occur in the central nervous system in response to disorders like multiple sclerosis. Inflammation is associated with diseases like Parkinson's. There's some controversial discussion about how involved it may be in diseases like Alzheimer's disease or autism. So there are neuroinflammatory diseases, and then there are actually also a large number of viruses that can infect the brain. Most people, I think, are probably familiar with viruses like poliovirus or rabies virus that can get into the brain. But it turns out that there are lots of other pathogens that you typically wouldn't associate with the central nervous system that can, albeit rarely, gain access to neural tissues. And those include the flu and measles virus and many herpes viruses. And so our interest is to try and understand how the immune response and the central nervous system work together. And why I think at a sort of almost more philosophical or bigger level, why that's interesting is that the rest of your body, apart from your central nervous system, can tolerate a substantial amount of swelling and inflammation, which is all sort of part of the healing and resolution process. But that same swelling that would occur in the central nervous system would likely be lethal because your brain is protected by bone, which is good, but it's also a risk because it doesn't allow for a lot of inflammation to occur. And so a lot of what my lab is currently focused on is how the immune response is tailored or is distinct in the context of the brain from how it might function in the periphery.
Certainly. Well, Glenn, you are doing some intriguing research really at the intersection, like you're describing here, of the immune system, neuroscience, as well as these clinical, relationships that you're forming with the research there. So that is really interesting. And with all the work that you're doing in the lab, I know scientists tend to keep so busy doing research. I'm always curious to hear about how people balance it all. What motivates them? How do you get everything done in a day? So can you tell us about a motivational quote or maybe a saying that really resonates with you?
Right, because I could potentially be your negative control for this, right. For how to balance it. The balancing is a constant challenge, and we can talk more about that if you choose as time goes on, because I'm still, at 51 years old, I'm still not sure I've got it right. Each time I kind of tweak and try a little something different, and it's worked reasonably well so far. But one thing I've found, and I do have a quote for you, and I didn't even have to look far for it, because it is literally sort of pasted next to my computer on my wall, because I grow weary of people who complain and who lament. So as frustrating as elements of my job can be, I absolutely love what I do. And like many, I'm sure, of your previous interviewees, view this as just such a distinct privilege to get to poke around in how things are the way they are and just, shine a little bit of a pen light on a corner of it. And so I get easily frustrated with whiners. And so the quote, long-windedly for me to finally get to it, is George Bernard Shaw, and it's not part of a play he wrote or part of other literature. It's actually part of a dedicatory to a book he wrote called Man and Superman. And the quote is, "This is the true joy in life, the being used for a purpose, recognized by yourself as a mighty one, the being thoroughly worn out before you are thrown on the scrap heap, the being a force of nature instead of a feverish, selfish little clod of ailments and grievances, complaining that the world will not devote itself to making you happy."
I like that quote.
It's a little long for a tombstone, but man, if I could fit that on my tombstone, I would happily do so.
Well, it's wonderful that you keep this quote so handy right next to this pile of classical CDs, I'm imagining.
The CDs are on the right, and my George Bernard Shaw quote is on the left.
Everything you need within reach. Yeah.
I'm kind of surrounded by these things, yeah.
Well, that is a wonderful quote. And I think important in the world of science to really focus on your attitude and not being one of these whiners, not complaining when things go wrong, but really seeing it as an opportunity, seeing it as part of your purpose. I love that.
Well, and it's not that the complaints aren't valid. Oftentimes for colleagues of mine, the laments are absolutely correct. And in fact, they're so correct that I could say verbatim. I could say exactly what they said to me. I could share the same with them. It's just that at the end of that conversation, I don't necessarily think we've solved problems. You could lament the state of funding or politics within a particular work environment, but those are not necessarily things that we're able to fix. And so to focus your efforts on the things you can change and the things you can manage, which fortunately are plentiful, seems like a better use of time, at least from my perspective.
Certainly. I like this, focusing on those more productive conversations and more productive ways you could be putting your efforts forward. I like that. So can you tell us a little bit next about maybe some of these people along the way who've really inspired you or maybe served as role models for you?
I feel truly blessed, Marie, in this regard. I mean, I feel like I've been surrounded by people who have been not only good role models, but good role models because they've never told me, listen here, son, do what I tell you. But they've been role models because they've given me an opportunity to watch how they do things. And actually sometimes role models are negative. I won't talk about those specifically, but sometimes you actually learn from people what you absolutely don't want to make as part of your professional career or how you want to interact with people. I think there's times where they can be negative as well, but I'll give you, among the happy many that have influenced me, I'll tell you two. So one is personal and one's professional. So the personal one is actually my grandfather, which I suspect for a lot of people, they'll refer to a parent or to a grandparent as impactful. But my grandfather came to the United States before World War I as a child from Austria. And he came to be with his father. And he, I think, left Austria when he was in the equivalent of 6th or 7th grade. And the intent was eventually to move the entire family, which included my grandfather's brother and sister, and the mother eventually moved the whole family over to the United States. But once he arrived in the U.S., World War I broke out. And my grandfather's father, who was a military officer, had to go back to Austria. And that was the last that my grandfather heard or saw of any of his family. They were apparently all killed in the war. And so here was this kid at the age of about 13, 14, 15, living in New York City on his own with no language and no real education.
Oh, wow.
And he not only was able to survive despite many tough times that would fill countless hours. In fact, I actually recorded him. He's died many years ago, but I have all of these tapes of conversations with him because I just thought this was such an inspiring story that I wanted my grandkids to be able to hear their great-great-grandfather was and what hardships this guy had. But what I loved about this guy was that he became a tailor in New York City, and he would take the train into New York from New Jersey, where he was living. This is many years later once he was an adult. And instead of taking the bus from Grand Central Station to Finchley's, the clothing store that he worked, he would walk. And that would save him, I think, a nickel or some small amount of money, which he would set aside. And when he had enough, he would go into this bookstore and he would buy books of philosophy. And what's amazing is I have all these books, and he would annotate them. So he'd underline and he'd write notes in the margin. And I've read many of these books, and he got it right. Like, he knew what the important points were. And what I loved about this was here's this guy where English was not his first language and where he had no formal education, and yet he had such a thirst for learning more things and for improving himself. Fortunately, he was part of my life all the way through my late 20s. And so he really had an influence, not so much as a scientist, but more about just this passion for, well, to the quote, to being thoroughly worn out before you're thrown on the scrap heap, just sort of taking as much advantage of the time we have as we can. So he's been a sure role model for me. From a professional standpoint, I have a colleague, Lynn Enquist, who's at Princeton and was the former chairman of the molecular biology department at Princeton. He's about 10 years older than me, and I've known him since graduate school. And Lynn has been a really important role model as well for how to gracefully do this balance that you've brought up before, how you are both a scientist, an administrator, a mentor, and then personally how you are a partner and a parent and the child of parents and all of these other things.
Some people just make it look easy, right?
Yeah, and it's heartening that people can do it and maddening that he makes it look easy, and I see he does this with such grace, and I kind of continue to look, and I know him very well, so there have been plenty of times I've looked and he just gives me this Cheshire Cat smile, which is equally maddening. But I would say those are certainly two of a number of folks who have been important as I've grown up scientifically and personally.
Well, it's wonderful to hear about some of these people who were really instrumental to shaping your life, shaping how you think about things, both personally and professionally. And I think the story of your grandfather is just awe-inspiring. I can't imagine being at that age, sort of left to your own devices in a new place, completely unfamiliar with the culture, unfamiliar with the language. So really inspiring to hear that he was able to put everything together and build a wonderful career, have a great family, things like that.
It does snap things into perspective pretty quickly, you know? I mean, because when we worry about a paper not getting accepted or all the rest, I mean, yes, these are obstacles, they're challenges, they're frustrations, but on the 1 to 10 scale of emergencies, these are 2s and 3s.
You'll probably survive,
It's not like I'm in a foreign country, I'm a teenager, and I have no education, right? So,
right. Well, those are wonderful stories about these mentors and the impact they've had on your life. And I'm curious, Glenn, to hear about what got you going down the scientific path to begin with. What really sparked your interest in science?
Yeah, so I don't belong here.
Most of us feel like we don't, yeah.
Oh, no. You know, and actually, like, this is important because I do worry. One of my jobs here is I direct our postdoc program. And I interact with postdocs, but we also bring in high school kids and undergraduates. And I think often they make the mistake in looking at people who are professors and they think, oh, I could never be them. You know, they must have had this drive from early age. They had this
Day two,
linear, and my career path has been so almost mercilessly Brownian in terms of bouncing off of things and ending up in places that I didn't predict. So as I said, I'm 51. So when Apollo 11 landed, I was 6 years old, and I was wildly influenceable by the majesty of space. And so I thought right there and then at 6 that I was going to be an astronaut. Mm-hmm. And my poor mother, we had the stars and moon sheets for my bed, and we had the stuff up on the ceiling, and I forced her to buy Tang. And I was...
It's all to be expected. It's all part of the journey. It's all to be expected. Yeah.
And what I think I neglected to recognize is that you actually have to have some physical acumen as well. And I'm chubby and graceless. And so fairly early, I realized, that my dream of becoming a space frontiersman was not likely to happen. When I was in high school, I was a kid's birthday party magician.
Really?
Yes. I was good. I did like 6 or 7 birthday parties on a Saturday. I didn't have an assistant, and I didn't have animals. That was a rule that my mother, not the assistant part, but the animals part was a rule that my mother enforced. But yeah, it was good. And actually, I will say this was tremendous training for now, because I give seminars and sometimes you get snarky questions or, a little bit of a difficult audience, but they are child's play compared to doing a magic show in front of a group of 8-year-old boys.
Really?
That is an impossible audience. And so to some degree, I cut my teeth on these ridiculously impossible audiences of little boys who'd scream out, "I know how you did that," and would just boldly run up to you and grab the trick right out of your hand. Mm-hmm. So I did that actually through high school. And all through this, I worked at day camps. I was a lifeguard for a while. So I thought, I'm going to be a pediatrician because I liked kids. I liked science, biology at least. And so when I went off to college as a biology major, it was completely with the expectation that I would end up as a pediatrician. And I actually think had that been the course that I'd taken, I think I would have been fine. I'm a little anxious about how I would have interfaced with the parents, but I think interfacing with the kids, I would have been okay with. My family contends that I am indeed that same 8-year-old boy trapped in this body now. So
you'd be the cool doctor, yeah.
Well, yeah. Well, I don't know. Probably wildly inappropriate, but at least... But when I was in college at Lafayette, actually, so Lafayette was a small academic teaching school, really good school, but not known for its, blockbuster science. But one of the professors actually had gotten a grant to study bacterial populations in lakes in the Poconos. So I went to Lafayette, which is in eastern Pennsylvania, which is near the Pocono Mountains, where there are many small, beautiful lakes, but many of them had been impacted by acid rain, very hot topic back in the 1980s. And so this project was funded by the local electric company to measure bacterial populations. And then almost impractically, when the lakes froze over in the winter, they neutralized one of the lakes by dumping a ridiculous amount of limestone on top of the lake. And indeed, they brought the pH of the whole lake from, I think it was 4.9 up to about 6.2, which is actually a pretty rational, reasonable pH for a lake.
Yeah.
And my job was to assess bacterial populations before and after this neutralization event. And I thought that was kind of cool. And it was the first time I'd been introduced into research at all. And so I began then to think, well, maybe graduate school was for me. And candidly, I didn't do terrifically well in classes like organic chemistry and all of the other necessary hoops that you have to jump through in order to qualify for a good medical school. So at that point, about halfway through college, I decided, all right, I'll apply to graduate schools. And I rather liked environmental bacteriology, since that's the only exposure that I'd had. And one of the schools that I'd gotten a scholarship at was Vanderbilt, that had a little bit of that, but actually had a lot of virology. And so when I did my lab rotations, I ended up really loving the study of viruses. They just seemed insidious and scary, but wickedly cool. And so I ended up working with Tamar Ben-Parat, who was one of the old-time herpes virologists, and had a great experience with her. She was a tremendous role model as well in terms of her science. And kind of backed my way into studying viral pathogenesis, because sort of toward the tail end of my PhD, I began doing a little bit about how viruses cause disease. That was the very end of my graduate work. And that I thought was really cool. And this was back in the, what I guess now, early 90s, when very little was understood about how the immune response functioned in vivo in totality. And papers were just beginning to come out in that discipline. So that felt like a brave new world. And that's sort of what got me out to Scripps, where I did my postdoc with Mike Oldstone, who's kind of a main father figure in the viral pathogenesis field. So, but purely accidental. In fact, even getting here was a bit of a surprise, because I thought, oh, I'll be a teacher. Clearly I like to talk, right? So
you like kids, you like talking. I like it. Yeah.
Yeah. And so I felt like, okay, teaching, I can do this for sure. But when I started looking at the opportunity of doing academic research positions, like here, that had its appeal as well. And this also brought me personally, for my wife and I, closer to home, because we had been living in San Diego at that point. So for all those reasons, I landed here at the Cancer Center, and I've been extraordinarily happy here for, like 19 years. So.
Well, it is just phenomenal to hear about your journey and how your interest maybe shifted throughout the course of your career, starting with wanting to be an astronaut. I think that was a lot of kids were in that boat as well.
Yes, I was not alone.
Yeah.
It would have been a very tight space shuttle if we fit all in there,
That's right. We should start a group of sort of recovered aspiring astronauts and scientists. But certainly great to hear about how you got to where you are today. And I'm curious to hear a little bit more about one of these projects that you're working on, maybe one that you are the most excited about, Glenn.
Oh, I can tell you, I'm very excited about this one. So the lab has 3 themes. And don't worry, I'm not going to tell you all of the themes. But the first 2, which were sort of the heart and soul of my first 15 years of working here, were very much working with a mouse model system of measles virus infection in the brain. So we made these transgenic animals, which are permissive, because mice are normally not permissive for measles virus. So we developed this model system where only neurons could be infected, and that allowed us to tease apart very sort of particular aspects of how viruses move within neurons and how the immune response recognizes an infected neuron, because for all sorts of interesting reasons that we're not going to go into, neurons, again, are different from the average cell in terms of the molecules that it expresses and how the immune response sees it. But all throughout this process, I'm very anxious using, not because they're an animal model system, but because we tend to treat them as like mini humans. We all know that they're not, but they tend to be surrogates in that sense. And from an immunological perspective, I think that's a huge trap, because obviously, when a human is infected with a virus, if you or I got sick tomorrow, to some degree, our response to that infection is going to be predicated upon all of our previous responses. And genetics are going to play a role in whether we get sick, whether we fight the infection quickly, slowly, not at all. Inbred mice don't have that kind of flexibility. And so as a consequence, that's one of the reasons why they're quite different. But the other thing is that when viral pathogenesis people study virus model systems in animals, we tend to use just one virus at a time, right? So I get my nice clean mouse out of the colony, I infect it with whatever virus I'm interested in, I look at the parameter I care about, and then the experiment is done and the mouse is gone. But humans might actually be infected with multiple things simultaneously, right? You might have a viral infection and then you might get a bacterial infection on top of it. Or you may have just had a vaccination and you end up encountering a different bacterial infection.
It's always more complicated in real life. Yeah.
And so the field of immunology is predicated on this exquisite way in which the immune response gets educated. But actually, the trafficking, how immune cells know where to go within the host, is not very precise, not antigen-driven. It's chemokine gradients and adhesion molecules. And so we began to wonder what happens if you're infected with two things. And you make an antivirus A response and an antivirus B response. Let's say virus A is in the brain, virus B is in the gut. Does the antiviral A response only go to the brain and the antivirus B response only go to the gut, or do you homogenize these responses? And if you do homogenize, can that result in unique diseases that you wouldn't see with either infection alone? That is, could there be some human illnesses that are consequences of, by obligation, polymicrobial or polyantigenic challenges? Does that make sense?
Certainly, yeah.
And so we actually used this mouse model system to begin to explore this. And indeed, we showed a couple of papers that were published a couple of years ago that indeed you do homogenize immune responses. And indeed, you do get unique diseases, especially within the central nervous system, when you do so. And so we're beginning now to take sort of another trip through this model system to understand more about the mechanism of how that disease occurs and what those immune cells that we're calling misrecruited, because they've been recruited to the site where no cognate antigen exists, where what they were trained to recognize isn't there, and yet somehow they're able to cause central nervous system disease. So that seems surprising and different to us. And so what a couple graduate students in the lab now are studying is how that works. But I'm happy with this because it feels like it's taking the mouse model a little bit closer. Maybe depends on, I guess, the audience, but it's maybe a baby step closer to what might in fact be true biology that's happening in infected people.
Certainly. Well, I think this is a fascinating project. I mean, I think in science, you always have to start with the very easiest scenario. But I think it's always really exciting when you hear about these situations where you're able to start examining these interactions, in this case of infections, and really starting to understand how that immune system is then handling these complex scenarios that are, like you're describing, more true to life, more true to what you would see in humans, because we are exposed to more than one thing at a time. It's not always this neat little infection where I was in the hospital for situation B,
Yeah, it's fun. It's scary because it is hard. I mean, it doesn't just make it twice as hard. I think it squares how challenging it is, right? Because now you've got lots of different players interacting, and animal model systems are complex anyway because you really can't truly control that experiment. You may not know all of the parameters that influence the outcome. And yet it also does feel exciting and important. So it's getting us to talk to people at Penn and at Jefferson, at Princeton, and, people that we normally wouldn't encounter. And that's sort of the fun of this, is that I get to have these new conversations and be kind of naive and let them tell me what they think is important and what's worth pursuing.
Absolutely. Definitely learning from those collaborators who have this unique perspective to bring to it. I think that's great. So, Glenn, I think so far, though, we have talked about all the wonderful aspects of your career as a scientist and as your journey to really get to where you are today. And we haven't yet talked about some of the stumbles along the way. And I know every scientist has these moments, maybe they're long moments, maybe days, weeks, even longer, where they look back and it was just a struggle. And maybe they had a major failure. And I think when you see science in the media, when you see papers come out, you only hear the success story. You don't hear about everything that came before it. So can you take us back to one of these difficult times in your career and tell us what happened and how you got through it?
You don't know it, but I just took the high road for not saying something wildly inappropriate for how I got through it. But yeah, I was just at the beginning of my starting to think about looking for career or jobs of permanence, I think is what we called it back then. And I had one figure that I still had to complete, and it was a very in vivo based project. So lots of mouse tissues, and it was a time course. So they were collected over multiple weeks, I think even maybe an order of a month, month and a half. They were all stored away in this freezer as I'd been collecting them, and then the time was almost ready for me to do, what was it? I guess it was Northern blot back then, on isolate RNA from all of these tissues and go. And literally the night before doing this experiment, the freezer died. And all of these samples, I came in the next morning, I opened up the door, and the first thing I noticed was this terrible, like this sort of wrong smell. You know, like you opened up the freezer and right off the bat, even before I realized, oh no, the freezer died, you just knew that things were terribly bad and that it had been that way for a while. It wasn't like there was even any hope of quickly freezing down and resting.
Salvaging. Yeah.
And so I remember like just palm sweaty, still trying to isolate RNA from these tissues, but knowing for sure that they weren't going to work. And indeed, you know, we were all the way down to individual nucleotides, I think, in degradation by the point that I tried to isolate it. And this was terrifying because I had spent so much time doing this, and more than ever in my career, I'd felt backed up against the wall in terms of time. I mean, all of us know that science takes time and they have setbacks and that the cadence of science is somewhat slow. But this was really upsetting because I needed to get this piece of data, to get the paper, to get the job that I really wanted to be starting to apply for. And honestly, I don't know how I got through it. Like, I wish I could say that I had like some epiphany.
Some pearls of wisdom here.
Yeah, and you know, that I could encourage someone who might be in a similar awful situation. But I didn't. I know I cursed, and I know that I complained and lamented to some of my peers, all of whom were sympathetic, but none of whom could fix my problem. And I think I eventually just realized, okay, this is the job of the scientist. You go back again because there is no other opportunity. There is no alternative. We're taught to think, okay, you do an experiment, and what are the 2 or 3 or 10 different possible outcomes that you could get? So you tend to apply this to life in general, like, all right, here's my problem. What are my possible solutions? But sometimes there's only one solution, which is, yes, this is too bad. Start again.
Right.
And so I think that very afternoon, I just started again, and it went fine. And I put them in a freezer that I could trust, and you know, things moved on. But at that moment, it was crushing because you just felt powerless. And it is a bit of a nightmare. And in retrospect, even though at the time, all my colleagues who were providing support, they weren't fixing my problem because they couldn't. In retrospect, actually, having other people that I could talk to did make a difference, right? Other people that you could share this with, and that you realized that you weren't alone, that there was no...
You guys could kick the freezer together, yeah.
That's right. You know, that there was no global plan to make my life miserable, but just that sometimes these things occur. And that I found was of some comfort, but I had no other choice. What else was I going to do except begin again?
Right. So the story does have a happy ending, though, because you did get the job. So what happened? Did you start over and everything worked?
But isn't that wild? Because I have no idea if the jobs that I applied to might be different. I mean, it did delay things, indeed, right? So I remember thinking about this as a kid, like the lives that we're living now are one of a billion possible lives based upon these little things that occur, and not major decisions like where you're going to go to college or who you decide to marry, but sometimes just little things like, a freezer died, and how that influenced then what possible jobs I could apply to and what life I'm living now versus had that freezer not died. I can get myself completely spun around in these sorts of thoughts, like all of the other lives not lived. But,
right. You might have that freezer to thank. Yeah.
Yeah.
Well, I think it's these unforeseeable events, these things that happen that you're absolutely right are not one of those 3 possible outcomes that you were ready for, that really, I think, show people's character, and how they deal with some of these setbacks is so important for how they're going to proceed along their career, because there are so many setbacks in science that I like that you had this moment of sort of self-indulgence, complaining, being upset, but then you got back to work. I think that's so important.
I did go drinking that night.
Right.
I don't know what that says about my character,
but you got back on that horse. I like it.
Eventually, right back on the horse, yes.
Absolutely. Well, Glenn, great to hear about one of these challenging periods and how you worked through it and really continue to go on to have a successful career. I think it's so great for people to hear out there that having one of these world come crashing down moments does not mean the end of your career. So great to hear how you work through that tough time. And I know scientists keep so busy with all the work they're trying to do and trying to balance everything. We've talked about this a couple times. And I know it doesn't always leave a ton of free time, but it looks like you've got a little bit of extra free time on your hand now with the kids out of the house. Are you going to start picking up reading? And maybe do you have a particular book that you'd recommend for us and our listeners to really indulge in?
So every day, this is my vacation, Marie. So ever since I was a kid, I end the day by I have to. It doesn't matter what time it is. I need to just sort of sit quietly for a half an hour, 45 minutes, and read. It's sort of my pre-going to bed ritual. And so I try and read a lot. And it's getting harder as I get older because But at the end of the day, I'm tired. And so embarrassingly, I'm the guy that will fall asleep sometimes after just barely getting through a page. But I do read a lot, and I'm pretty agnostic about the stuff that I read. I read a lot of fiction, but I'm lately getting much more into nonfiction, history kinds of things because a little bit associated with travel, I like to go to these places and sort of see where it is and then find out more about it in retrospect. But so, yes, a book to recommend. I believe David Mitchell can do no wrong. So this is not a science book. He's a guy who wrote, now I'm going to forget them all. Ghost Written is one. Cloud Atlas, that was turned into a movie, is one. Number 9 Dream. These are all wonderful books. I heartily endorse them. They're wildly inventive and creative. They're a little gimmicky, but there are tremendous stories that are in there as well. But the one that I just read is actually not in any way a fictional trick. It is just a wonderfully spun, complex, rewarding narrative, and it's called The Thousand Autumns of Jacob de Zoet. You heard of this book at all?
I have not.
Oh, it is truly this good. It is outrageously funny. It's unlike anything you've ever read, just in terms of the characters that he develops and how he has them interface with each other. It's hard, actually. It takes a little bit of work to get through because he doesn't spoon feed you. So there are things that happen among these characters that you know about only because of their conversations, not because he comes right out and says, then this person did this. And so you have to really be on your toes. But it's among the most rewarding pieces of fiction I've read in many years. And I've actually given it to a couple of colleagues here who have endorsed it as well. So this gets, multiple stars from us.
Well, that sounds great.
I'll give you one other, a science book that I like, and it's completely different. So it's a very old book by Cedric Mims, M-I-M-S. And I think it's called The Pathogenesis of Infectious Diseases, I think is the title. But if they look up MIMS and infectious diseases, they'll find it. And what's great about this book is it's very early. It was written some time ago, and I think there have been 4 or 5 editions since. But it's an effort to look at all infectious diseases, right? So it's not just viruses or bacteria or parasites or fungi. It's sort of taking them in totality about how critters out there can make us sick. And it is a really very grand effort to try and incorporate all of these very different kinds of pathogens with very different lifestyles and very different features into some kind of global thesis. And yet he does it, and he gets it right. So the observations that he makes from the perspective of being an infectious diseases guy, as opposed to being, more binned into one of these, virologist, bacteriologist categories, I just thought was masterful. So it's as much fun to read from its historical value as it is for the science. And it's also funny. It's a really enjoyable read, which is hard to come by in science, I think, sometimes.
Well, those sound like outstanding recommendations. I'll make sure not to read them on the metro. I know I try to avoid funny books, so I'm not laughing to myself on the train, suddenly finding myself with more room. Yeah.
Yeah. Well, both of them could make you laugh out loud, so they may be warnings there for you. But,
read cautiously. Well, great recommendations. And you mentioned in talking about books that you like to read, you like getting books about places and learning more about different places. And I think that's a great opportunity that scientists have, is being able to travel to different places, to go to conferences, to experience new lands. Can you think back on these places that you've traveled for science and tell us about one of your favorites?
I will. So I was invited to talk at a neurovirology meeting in Sardinia. And so Sardinia, and I'm going to say this, and I hope that this doesn't sound insulting because I didn't actually know about it beforehand. Sardinia is one of the islands off of Italy. Did you know this?
I did.
You did? Okay.
But I'm fairly good with European geography.
Well, that's impressive.
Take me anywhere else and I'm lost, though.
All right, fine. Be self-deprecating. So it was in a town called Alghero. So this is on the west side of Italy, very firmly planted right in the plunk in the middle of the Mediterranean. And so I get to the meeting and there's a conference center and all the rest, and I'm one of the speakers. And I arrive and I said, I'm Dr. Rall, where's my room? And they're like, oh, you're in the other hotel. And I said, okay, where's that? And they said, that's on the other side of town. And initially, I was a little uppity about this. Not to them. I felt a little put out because I thought I would like to be, where I just have to roll down the stairs and there's
where the action is, yeah.
But the other side of town was about 2 miles across this small town, Alghero, Alghero, right on the coast. And my hotel was not particularly impressive on the other side of town. But what it made me do is that twice a day, I had to walk that distance, right? I had to walk over from my hotel and back at night. And that meant that I had to walk through this town. And it was, I want to be careful because I think some words get overused, but when I say magical, it really felt this way because at night, this town woke up. And everyone came out. They brought out their bottles of wine. Their kids were playing in the piazza. There were these beautiful lights that were hung all over so that there was this, this sort of warm light. And people just were hanging out, talking with each other. There was just this sense, it was almost like a gigantic community party. But it happened at least every night that I was at the meeting. And presumably, this is the way that things go. And I remember just thinking two things. First, I'm so glad I didn't get a room in the hotel that the conference was at because I never would have seen this. I might have taken a little day trip into the town, but I never would have become so connected and familiar with it. But the other thing is I felt a little sad because there isn't anything quite equivalent to this in the United States. I mean, we'll have block parties or other parties, but there isn't that sense of just where an entire community gathers with such frequency. And it just felt charming and healthy. And for at least a short period of time, I thought, I like this. I could very easily imagine being part of this. And I know that I couldn't, and I'd be the strange guy from Pennsylvania. Why is he living in Algero? But for a moment, I was really quite captivated by this. And to your point, this was a happy byproduct of what was, in fact, a good science meeting. But the part that I remember most from that conference was just this opportunity to kind of wander through almost a little bit invisibly through the town in the evenings. So
Well, I love this description, almost as the fly on the wall, just watching the scene unfold every morning and every evening. And it sounds quite spectacular being able to walk through Algero and just all the almost hustle and bustle of the small town. And it's almost just a great sense of community I'm feeling, even just as you're describing it.
Yep. I felt very isolated a little because, at one point I was walking because I still had to present a poster. And so this is when we used to carry poster, in those poster canisters.
Oh, yes.
And people were like, who is this guy? What is that thing he's carrying? Why is he walking so fast? I definitely did not feel part of it. I couldn't kind of...
You weren't blending.
Yeah, no blending going on here at all.
Gotcha. Well, that sounds like a wonderful experience, though. And I think that is part of the joy of being able to go to these conferences, is just to experience a little bit of the culture, get a little taste of a different place. And I think a lot of us have gotten to that point where we're like, oh, I could stay here. I could make this work.
Yes. If my plane were canceled, I'd be okay with that.
I wouldn't cry. Yeah.
Yeah, that's okay.
Well, that is a wonderful experience. And I think in addition to some of these travel opportunities, scientists get a lot of great opportunities to just work with wonderful people. And when you look back over all these groups that you've been a part of, maybe throughout your graduate school years, postdoc, and even at the Fox Chase Cancer Center, I think there's just some amazing personalities that emerge. And when you put so many bright, brilliant people together, I think you get some quirky traditions that spring up and even just some funny memories. So can you share one of these funny memories or traditions with us today, Glenn?
Well, I don't know if it's a tradition. It's a thing we do in our lab. So, I care very much that the environment that I create in my lab is a supportive and happy place. And I don't mean to be glib or trite about this, but I actually think, this job is different from working at a bookstore or working somewhere else, that there are personal demands. You don't get particularly well compensated. Even once you become faculty, it's relative to what you might be making if you worked elsewhere. It's not quite the same. So I feel like part of my job is to create an environment here that people are happy to come to. And so were you to see my lab, we have Christmas lights on all year round. And one of the things we have is a dartboard, and it's on my door. And no, my picture is not on the dartboard. It may be on the dartboard when I go out of town, but not that I'm aware of. Nobody's left it there by accident. So we play darts in the lab. Not all the time. We actually haven't done it in a few months, but it's official. It's not like one of those cheesy ones with the plastic darts. It's bona fide darts. We've drawn the line with purple lab tape, 7 feet back, which is where it's supposed to be. And we play games of cricket, but we talk about science while we're doing it as well. And we also have a game of Boggle that we play every once in a while in here, but I tend not to like to play that because I've never won. So,
really?
Yeah, Chris in my lab always comes up with words that I'm flabbergasted. I'm finding words like and for, and
right.
She's finding words like Zephyr. And so I'm hopeless, and so we don't play that. But darts, I can actually be competitive. But I don't know if it's a quirky tradition, but it's an opportunity for us by doing something else almost liberates your brain to then think about science. Because there's a little bit of a mindlessness to playing darts, right? You just stand there and you aim for numbers and you toss. It doesn't require huge amounts of concentration. But I found that we can actually have really productive, thoughtful conversations rather than everybody sitting around some table in a anodyne conference room somewhere. This makes it a little bit more lively and a bit more interactive. So does that count? Is that what you were looking for?
Absolutely. I think those are great little traditions or even just memories that you've shared with your lab, spending time playing darts. I'm actually quite good at Boggle, but terrible at darts. So
you'd find Zephyr, wouldn't you?
Yes, I might find Zephyr. No.
This is a little intimidating because your European geography. You have formidable skills.
Can we challenge each other to a dart match and a Boggle tournament?
I have a feeling one of us would win one each.
Right. I'm okay with that.
Okay, fair enough.
Those are some great traditions. And I really like that you're describing making an effort to make the lab fun for people who are there and make it more of a community, not just a place that you go to do work. I think in addition to chatting with people about science and about life, I think a lot of scientists really enjoy talking about these hypothetical, these big questions, these things that they are dying to know the answer to. And maybe this is part of your DART conversation. But can you share with us today if things like funding and staff and technology and feasibility, all these constraints on research were not an issue? What is one question, Glenn, that you are dying to know the answer to?
So I don't think this is particularly creative, but it is a sincere answer, which is you're a neuroscientist, right?
Correct.
Yes. So one of the biggest meetings is the neuroscience meeting. Tens of thousands of people go to this thing annually. And yet the basic elements of who we are is still anathema, right? I mean, we understand a little bit about memory compartmentalization and a little bit about how neurons cooperate and work in networks. And so we're certainly making progress and headway there. But I wonder whether when we finally understand who we are and how memories are preserved and how emotions dictate action and all those things, whether that's purely going to be in the domain of chemistry and biology, or whether that's also philosophy. Do you know what I mean? Mm-hmm. Like, I wonder whether just figuring out calcium ions going here and there can actually account for why I married who I did, or why these things make me happy, why I love this particular kind of music versus another kind of music. I'm wondering whether at some point science will ever actually know the answers to those things. Now, even with unlimited resources and money and time, I don't have the intelligence, the creativity, the tools. I wouldn't even know how to begin this. But this is one of those big questions with capital B and Q that I would really, really love to understand better, whether any question in the sciences can be answered by experimentation or whether there are some things that lie outside of our reach.
Certainly. I think that is an amazing question, really, whether we can almost make a super complex equation where we factor in all of our experiences, all of our biology, all of our chemistry to figure out why we act the way we do. I think these are some really big questions that a lot of people in science, and particularly I think in neuroscience, really think about.
Do you think we can? What do you think?
I don't know. I think we definitely won't be able to do it anytime soon.
Right.
So, I mean, I think that's one of those things where especially factoring in things like previous experience is so complex. I think you're absolutely right. Where do you start in terms of trying to put a model together, in terms of trying to figure that out?
Would you be disappointed if it did come down to calcium ions?
I think I would be fascinated. I don't think I'd be disappointed.
That's interesting. That's what I say. I mean, because this gets actually very spiritual pretty quickly, right? And that wasn't my intent to direct it in that way. But I don't know if somebody said, here you go, here's the envelope, open it up, the answer is in here. If the answer was, yep, it's all chemistry, if I wouldn't find that to be limiting versus freeing. Do you know what I mean?
Yeah, I gotcha.
I think you're right. This is not something that we're likely to know in the short term. So this will be, I think, for me at least, an unanswered question.
Right. We can ponder this for the rest of our lives, Glenn. Well, that is a great question to think about. And, I think it's really fascinating to hear about these things that are really on scientists' minds, whether we're going to be able to achieve them or not in our lifetimes. So great to hear what's on your mind. And I think over the course of our careers, scientists get a lot of fantastic advice and wisdom passed on to them. Can you share with us today, Glenn, a piece of advice or maybe one last piece of inspiration that you want to share with our listeners?
No, Marie, I can't. I actually thought about this a bit, where I was like, was there this moment, where someone said plastics to me and I was like, yes, that's
it. Yeah.
There it is. And no, honestly, despite a life filled with people who I really do see as role models and who've been guides and supporters and mentors and trainers and negative role models and all of those things. There is not a moment where any of them, including my grandfather, sort of sat me down and said, here it is. This is a distilled, perfect piece of information that I'm giving you as a gift. Never once. Maybe people have tried, but I don't think it stuck with me. It didn't impact me particularly. I think the only thing that I really have valued, despite me talking, which feels like endlessly over the last hour, is that I'm pretty good at observing and watching. And I find that I learn a lot by stealing from other people, not literally,
right?
By sort of looking at a trait or an attribute, especially when I was first getting started, and saying, wow, I really liked how they did that. So I do this in seminars. If I go into a seminar and it turns out I really don't particularly like what they're working on, or I don't care very much, I still feel like I can get value out of it because maybe how they presented data or how they described a particular thing, or again, the opposite. I hated how they presented that or how they described a particular experiment. All of those things I try and then build into how I do things myself. So to some degree, I'm this kind of messy combination of pieces of various other encounters that I've had. But I think this idea of being open and receptive and being aware that there are other ways of thinking about things and other ways of doing things, it strikes me as strange and limiting that there are scientists who can be so immovable in their viewpoint. Like, if anyone's going to be open-minded, it should be a scientist. And I guess if I'm giving advice, it would simply be that. Watch, look, steal, figure out how you can incorporate some of the values and attributes you see in other people into your own careers. It's how we evolve individually. And I don't know if that's meaningful or not, but I think it has been something rather than any particular direct quote or thing that someone has charged me with that I've found has been valuable for my own development.
Certainly. Well, I think that is great advice, to learn from the people around you and to be flexible and pick up on these little traits, these characteristics that you admire in other people. I think that's wonderful advice. Now, Glenn, we've had some fantastic conversations today. Can you tell our listeners how they can reach out to learn more about you or your research?
Oh, sure. Right. I love talking to people about science and about careers and things along those lines. So probably the best way, because unfortunately my schedule is full of meetings, so the best way to get me is probably by email. My email address is my name, so Glenn, Glenn .Rall @fccc.edu. Or if you just go to the Fox Chase Cancer Center website, you'll find me, I think, pretty easily. And I actually respond to emails. So that would be the best way if anybody wanted to find out more about my failed astronaut past.
All right. Well, that is wonderful. Listeners, definitely reach out to Glenn if you have any questions. And Glenn, thank you so much for joining us today and sharing a piece of your story.
This has been great fun. We don't get a chance to do this very often, and I really endorse this effort, Bree, because I think getting to hear about some of the histories of people and scientists gives you some insight into their work. So it was fun to talk about me for the last hour. So thanks for the invitation.
Certainly. Well, it was wonderful to chat with you as well, Glenn. Thank you so much again. And thank you to our listeners for joining us as well. We'll see you next time on another episode of People Behind the Science. Your voyage to the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to seeing you next time on People Behind the Science.